Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Before we delve into the mysteries of metamorphism, let's take a moment to appreciate the wonders of our planet. Earth, a beautiful sphere spinning in the vast universe, is home to a myriad of geological wonders. From the towering mountains to the deepest ocean trenches, from the arid deserts to the lush rainforests, our planet is a treasure trove of natural beauty. Each landscape tells a unique story of formation and transformation, of creation and destruction, and of stability and change. It is this ever-changing nature of Earth that leads to the formation of the stunning metamorphic structures and textures that we will be exploring in this video. So, buckle up as we embark on a journey to understand the intricate processes that shape our beautiful planet. As we marvel at the wonders of our planet, let's take a moment to journey through the layers of the Earth. Imagine descending from the surface, through the crust, into the mantle, the outer core, and finally, the inner core. It's here, deep beneath the surface, where the magic of metamorphism begins. Under the immense heat and pressure, sediments and rocks undergo a transformation, a metamorphosis, if you will. Picture a humble piece of limestone buried deep within the Earth's crust. Over millions of years, under the intense heat and pressure, this limestone transforms into marble, a beautiful and prized stone. This is the journey that all metamorphic rocks undertake, a journey of transformation and change. As we venture further into this video, we'll explore the intricate processes and structures that define metamorphism. We'll unravel the mysteries of isograds and facies and take a deep dive into the fascinating world of metamorphic textures. So stay tuned as we delve deeper into the hidden wonders of our planet. From the depths of the Earth's layers where we left off, we now move on to the birthplace of metamorphic rocks. This is where the story of transformation truly begins. Imagine the intense heat and pressure bearing down on simple sedimentary rocks, pushing and pulling them, breaking them down and building them back up. The process is slow, taking millions of years, but the result is worth the wait. The once simple rocks emerge as complex structures, their grains aligned, their minerals reformed. They are now metamorphic rocks, the product of a process as old as the Earth itself. But how does this transformation happen? What forces are at work that cause such dramatic changes? And what can these metamorphic rocks tell us about the Earth's past and future? Join us as we delve into these mysteries and more in the coming scenes. Hold on to your seats as we explore the dynamic, changing and fascinating world of metamorphic geology. Our journey continues from the birth of metamorphic rocks, tracking the path of transformation, from simple sedimentary rocks to the complex metamorphic ones. Picture a sedimentary rock, a product of years of weathering and erosion, now embarking on a journey to the depths of the Earth. The pressure builds, the temperature rises, and the environment becomes more hostile. But remember, it is this very hostility that leads to the creation of something extraordinary. The rock undergoes physical and chemical changes, its minerals rearrange themselves, and its structure becomes more compact and crystalline. This is metamorphism in action. A process of transformation, a process of becoming. And the end product, a metamorphic rock, a testament to the power of change and the relentless forces of nature. But the journey doesn't end here. We have only just scratched the surface. Let's dive deeper into the mysteries of metamorphism in the next scene. Have you ever wondered how the majestic mountains and the beautiful stones we admire are formed? The answer lies in metamorphism, a geological process that creates stunning metamorphic structures and textures. Picture a rough rock subjected to intense heat and pressure, transforming into a dazzling gemstone or a towering mountain. These aren't just random occurrences, but intricate processes of change and formation. These structures and textures are not just remarkable works of nature, but are also a testament to the dynamic process of metamorphism. Metamorphism, in the simplest terms, is a process where rocks undergo transformation due to heat, pressure, or other natural agents. Think of metamorphism as a sort of rock alchemy. Its magic lies in its ability to transform one type of rock into another, essentially giving rocks a brand new identity. The primary agents of this transformative process are heat, pressure, and chemically active fluids. Now let's delve into the role of heat. Heat is a catalyst for change. It speeds up chemical reactions, causing minerals within the rocks to rearrange themselves into new, stable structures. Imagine a slab of limestone being thrust deep into the Earth's crust, where the temperature is high. Over time, the heat causes the limestone to morph into marble, a metamorphic rock. Next up is pressure, but not just any pressure. We're talking about the kind of pressure that comes from the immense weight of the Earth's crust. This pressure, also known as lithostatic pressure, squeezes the rock from all sides, forcing the minerals within to align themselves in new patterns. This realignment forms new, denser structures, changing the rock's original identity. Now, we can't discuss metamorphism without mentioning chemically active fluids. These are essentially hot, mineral-rich waters that seep into the rock's pores. These fluids can trigger chemical reactions, replacing the original minerals with new ones. An example of this is the transformation of basalt into greenstone. But it's important to note that these agents rarely work alone. More often than not, it's a combination of heat, pressure, and chemically active fluids that lead to the transformation of rocks. It's a symphony of natural forces, each playing their part in crafting the beautiful and diverse metamorphic rocks we see today. To sum it up, metamorphism is an intricate dance of transformation. It's about the old giving way to the new, the familiar morphing into the unfamiliar. It's a testament to the dynamic and ever-changing nature of our planet. This transformative process results in the formation of new minerals and structures, creating a metamorphic rock. In the world of metamorphic geology, the terms isograd and facies have special significance. Let's start with isograds. Isograds are essentially lines drawn on a map to mark the first appearance of a metamorphic mineral in rocks. Imagine them as invisible boundaries that delineate the metamorphic zones where specific minerals start to appear. They are like the growth rings of a tree, each one marking a new stage in the rock's metamorphic journey. Now, why is this important? Well, these mineral appearances are not random. They occur under specific temperature and pressure conditions. By mapping these isograds, geologists can infer the metamorphic conditions that existed during the formation of the rocks. It's like piecing together a puzzle of the Earth's past. Moving on to facies, the concept is a bit more complex. A metamorphic facies is a set of metamorphic rocks that share similar mineral assemblages and were formed under similar metamorphic conditions. Think of them as metamorphic siblings, born out of the same metamorphic conditions. What's fascinating about facies is that they allow us to understand the overall metamorphic environment of an area. For instance, if we find rocks of the green schist facies, we know that they were formed under relatively low temperatures and pressures. On the other hand, if we find rocks of the granulite facies, we understand that they were formed under high temperatures and pressures. Facies are not only about the present, though, they also provide valuable clues about the past. By studying the facies, we can determine the metamorphic history of an area, the temperatures, the pressures, the depths at which the metamorphism occurred. It's like reading the diary of the Earth, with each entry revealing a new chapter of its geological story. So, isograds and facies, in essence, are the signposts that guide us through the journey of a rock's metamorphic transformation. Now that we know what isograds and facies are, let's delve into why they are crucial for geologists. Isograds and facies aren't just geological jargon, they're tools, essential instruments in a geologist's toolbox. But why are they so important? Well, they play a pivotal role in mapping metamorphic zones, those areas of our planet that have been physically or chemically altered by heat, pressure, or other natural forces. Imagine you're a detective trying to solve a mystery. In this case, the mystery is the Earth's past, and isograds and facies are your clues. Isograds, with their distinct mineral compositions, are like fingerprints. They allow geologists to identify specific metamorphic zones, much like a detective would use fingerprints to identify a suspect. Facies, on the other hand, are akin to the suspect's profile. They provide a broader view, outlining the conditions under which a particular rock was formed. When geologists encounter a certain facies, they can infer the pressure and temperature conditions that existed during its formation. It's like piecing together the suspect's backstory. Together, isograds and facies enable geologists to create detailed maps of metamorphic zones. They help delineate the boundaries of these zones and provide insights into the metamorphic processes that have occurred. It's a bit like constructing a timeline of events in our detective analogy. But what's more, these concepts also aid in understanding the Earth's geological history. They offer a window into the past, allowing scientists to reconstruct historical geological events and processes. Just as a detective uses clues to piece together a narrative of what happened, geologists use isograds and facies to unravel the stories of our planet's past. In essence, these two concepts are the geological compasses, helping us navigate through the complexities of Earth's metamorphic history. Metamorphic structures and textures, isograds and facies are not just academic concepts, but they also tell the story of our Earth. The beauty of geology lies in its ability to provide a tangible record of the Earth's past. Metamorphic structures and textures, those seemingly random patterns and shapes we see in rocks, are in fact a chronicle of the Earth's history. They are the physical manifestations of the intense heat and pressure that our planet has undergone over billions of years. The metamorphic process is a testament to the resilience of the Earth. Just as a diamond is formed under extreme pressure, so too are these structures and textures. They stand as a testament to the Earth's ability to transform and adapt, to change, and yet remain constant. In the same way, isograds and facies are not just lines on a map or changes in mineral composition. They are the Earth's way of telling us about its past. They show us where and how the Earth has changed over time, revealing the complex interactions between the Earth's crust and the forces that shape it. By studying these metamorphic structures and textures, we can begin to understand the processes that have shaped our planet. We can see evidence of tectonic activity, of the movement of continents, of the rise and fall of mountain ranges. We can read the Earth's history in the rocks beneath our feet, and in doing so gain a deeper appreciation for the complexity and beauty of our planet. But more than that, these concepts also remind us of the dynamic nature of our world. The Earth is not a static entity, but a constantly changing, evolving planet. It reminds us that change is not only inevitable, but also necessary for growth and evolution. By understanding the processes that shape our world, we can truly appreciate the dynamic and ever-changing nature of our planet. This knowledge not only helps us appreciate the world around us, but also equips us to better protect and preserve it for future generations. We are, after all, just temporary custodians of this beautiful planet. In the end, the study of metamorphic structures and textures is a fascinating journey into the heart of our planet. We've delved into the complex transformation processes, unraveled the significance of isograds and facies, and pondered on the marvels of metamorphic structures. This intricate knowledge illuminates the tale of our Earth, etched in every stone and mountain. So the next time you see a mountain or a beautiful stone, remember the incredible journey it has taken to become what it is today. Thanks for watching us. Share our videos, subscribe our YouTube channel and press the bell icon and stay curious for new uploads.